4, you have two parts. Unit 4 में दो part है. First one is your magnetic circuits, and the second one is your single phase transformer, right? So in the first part, or in say, you can say unit 1 of this chapter, we will discuss about the basic magnetic circuits and some magnetic materials. So that is, what are the properties of magnetic materials, what are the different laws which governs a magnetic circuit, then how flux linkage takes place through the different components of a magnetic circuit, and how the inductance is produced, what are the different type of inductance, then how the energy is stored, what is the value of energy stored, then different type of induced EMFs, like statically and dynamically induced EMFs. Then also we will discuss about the properties of a magnetic material, and then how hysteresis and eddy current losses are taking place inside a magnetic material. That we will discuss in this unit 1 of this chapter. Basically, in your syllabus, if you have seen the syllabus, then just one word is written, two word for this part, magnetic circuit. Right, just it is mentioned in your unit 4, right? But we have to discuss basically mainly the different laws in a magnetic circuit. So basic terminologies which are used in a magnetic circuit already we have discussed in the last class, like flux, flux density, intensity, reluctance, these things we have discussed. And then in the second part of this chapter, you have single phase transformers. In the single phase transformer, we will study about its construction, then principle of operation, then how equivalent circuit parameters can be estimated in a single phase transformer, then how we can draw the phasor diagram, different losses taking place in a single phase transformer. Then in the testing part, we have to mainly study about OC and SC test. Apart from these two tests, there are several tests. For example, you can say Sampner's test, then how efficiency and voltage regulation and all day efficiencies are defined as well as determined in a single phase transformer, that we will discuss. And at last we will see the parallel operation of single phase transformer, but this is the second part of this unit. So let us now start the first part, which is your magnetic circuits. So this magnetic circuit, you can say that electromagnetic system is an important element of all rotating electrical machinery and static devices like transformers, right? तो जितने भी तुम्हारे rotating machines है, for example you can say DC machine or induction motors, all are rotating machines. So electromagnetic system is basically a compulsory unit or aspect in all such rotating machines, as well as a static device like transformer, right? Then its role is to create and control electromagnetic fields for electromagnetic energy conversion process, right? You know that there should be electromechanical energy conversion process in order to convert the either the electrical quantity to the mechanical quantity and vice versa, right? So electromechanical energy conversion happens with the help of magnetic field as a coupling medium. Means this conversion is only possible if we have a magnetic field in the two mediums, right? Suppose medium, I want to say that suppose I have a magnetic material for example, you can consider this again a core, rectangular core. So if we have a coil here, if another coil is here, then this electromechanical or EMEC only can take place only if there is a medium between the two coils, which is a your magnetic field through which मतलब एक मीडियम होना चाहिए जिसके थ्रू फ्लक्स जो है सो पास कर सकता हो, right? So this is basically example of a transformer, but if we are talking about electromagnetic energy conversion, electromechanical energy conversion principle, then in that case, for example, you can consider one DC machine where we have air as the medium between the stator and the rotor part, right? So there must be some magnetic field in the particular medium of the circuit, magnetic circuit. The closed path, this is the definition of your magnetic circuit. We have already discussed that the closed path followed by the magnetic flux is called a magnetic circuit. Now, this magnetic circuit can be made up of materials having higher value of permeability, such as iron, soft steel, etc. Right? Just a minute. तो ऐसा नॉर्मली ऐसे मैग्नेटिक मटेरियल का यूज किया जाता है विच हैज हायर वैल्यू परमिएबिलिटी, राइट? Because the magnetic materials having higher value of permeability will offer less reluctance. ठीक है, reluctance जो होगा that will be less for a magnetic material having high value permeability, and if reluctance will be less, this will imply that flux will be more, right? तो मेन वही है कि फ्लक्स जो होना चाहिए that should be more in any magnetic circuit, right? Now, you can take this as an example of magnetic circuit in which you must have an electromagnetic system. Then ferromagnetic core material should be there, exciting coil should be there. So this is your core. This is your core, which is made of which should be made up of the ferromagnetic materials. I have already given some example of such type of materials like CRGOS sheets. Details about the construction and property of these type of materials we will study in single phase transformer in the core section, right? How the core is developed and built, in that we will see that. Then there should be exciting coil. This is your exciting coil, which is wound on one of the limbs of this magnetic material. Then here we have considered in the coil as n number of turns. Then here we have considered that I is the magnitude of the current flowing through this exciting coil. Then there should be the establishment of magnetic field in this magnetic material. And how it will be possible? Because when you will excite this coil with the help of any voltage source, then flow of current I will be there, and based upon the magnitude of the current, there will be development of the lines of forces. You can see that these are the lines of forces or flux. ये हो जाएगा. Now the developed flux phi, suppose phi is the flux, here Hc is represented, that is represented by Hc, but let us consider this as phi. So that phi will flow through the core made up of the magnetic material, right? Now in this process, in the process of conversion of the flux through this core, there may be some leakage of the flux at the joint terminals. यहाँ पे there may be the possibility of leakage of the flux. तो ये सब leakage flux के बारे में जो है ट्रांसफार्मर सेक्शन में हम लोग डिटेल में पढ़ेंगे. बस ये समझो कि जितना टोटल फ्लक्स प्रोड्यूस हो रहा है, सो some part of the generated or developed flux may leak at the joints, because ये जो क्रॉस सेक्शन होता है, this is made up of your small laminated और thin laminated sheets. ये एक solid piece का नहीं बना होता है, ये laminations का बना होता है, CRGOS sheets का बना होता है. So all these laminated sheets are combined and stacked together in order to develop the transformer core. So in this process, जो भी ये सीट होता है, यहाँ पे some other magnetic materials are required in order to combine or stack these seats, CRGOS seats. So due to the difference in the property of the magnetic material, there may be some leakage of the flux taking place in the system. So now we will see some basic laws in a magnetic circuit. So magnetic field intensity produced in the core is H, and from Ampere circuital law तुम लोग पढ़े होगे basic physics में, which is H dot dl in a closed path is equal to Ni, right? So यहाँ से if further we extend this expression, means for a element of length, suppose a small length dl, if we calculate in that cross section, then we will get h dot l is equal to Ni, right? So from here you can write h is equal to Ni by L. So this is your basic Ampere's circuital law, right? Now H, you know that can be, this H is your magnetic field intensity, so it can be expressed in terms of the flux density. So B is your flux density. So in last class we have discussed that B can be written in terms of H using this expression mentioned by question 2. B is equal to mu H, right? So mu can further be written as mu is equal to mu naught into mu r, right? So using these two equations, means equation 1 and 2, you can further extend this equation in this form: B is equal to mu Ni by L, right? Means equation 1 क्या था? H is equal to Ni by L ampere turns per meter. So B is equal to mu H. So S is equal to B by mu. Then you will get this expression: B is equal to mu Ni by L. Right. Then here you can see that now if after calculating the total flux density B, we can easily calculate the flux flowing through the core. So flux flowing through the core, जो ये section cross section के through जो flux pass कर रहा था, phi, so that is basically phi is equal to BA, right? So if we are aware about the cross section area of the core, then using this expression phi is equal to BA, we can easily calculate the total flux through the, or traveling through the, flowing through the core, which is made up of the magnetic material, right? So from here you put the value of B in equation 4, then you will get this type of equation. Phi is equal to mu Ni by L into A. So this can further be written in terms of the MMF and the reluctance of the medium. So phi is equal to Ni by L by mu A, where L by mu A is basically your reluctance of the magnetic circuit, right? So Ni is nothing but MMF, means MMF, magnetic-motive force by reluctance. So this is one of the useful expression which you may require while solving the magnetic circuits, right? So अब MMF का क्या काम होता है and how it can be related with the electrical circuit, जैसे कि हम लोग analogous property last class में पढ़े थे electrical and magnetic circuits का. So we have seen the different term. So you know that for the flow of current in any electrical circuit, suppose this is a electrical circuit, we need EMF in order to flow the current. This voltage or EMF source or EMF drives the current flowing through the electrical circuit. So similarly in a magnetic circuit, बताओ? So in a magnetic circuit, your MMF is required for the flow of flux through the magnetic circuit, right? तो इसमें इस तरह से देख सकते हो द एनालॉगस नेचर ऑफ इलेक्ट्रिकल एंड magnetic circuit. So this one is your magnetic circuit, and this one is your electrical circuit. So we have discussed that EMF should be there in order to flow the current through the electrical circuit. So similarly, this is your MMF, and this is your flux which flows through the magnetic circuit, and this is the reluctance, right? So MMF is analogous to voltage or EMF source. So reluctance is analogous to resistance, and flux is analogous to current in a magnetic circuit, right? Then in the last class only we have done a comparison of magnetic and electrical circuits. We have seen that flux is there in a magnetic circuit, current is there in electrical circuit, reluctance is in a magnetic circuit, again that is analogous to resistance in any electric circuit. There is flux, current, MMF, EMF, permeability, conductivity. We have already discussed this, right? No need to go to detail now. So now based upon the previous formulas related to the magnetic field intensity, MMF, reluctance, flux density. So you can now solve these type of questions related to a magnetic circuit. So all of you please note down this example. So just using the formula you can solve it. इसको note कर लो.
सर वो उस फॉर्मूले में जो एल होता है वो क्या सर्किट की पूरी लेंथ होती है?
कौन सा?
सर वो जो फॉर्मूले में एल लिखते हैं, फाई वाले फॉर्मूला जो अभी दिखाया था आपने, सर
एक
एमएमएफ निकाल। यस सर। सर
एक
उसमें
मिनट. ये
ये सर, यस सर। सर इसमें जो म्यू एन आई वाई एल लिखा हुआ है सर, उसमें एल क्या सर्किट का पूरा लेंथ है?
ये सर्किट नहीं, जो तुम्हारा मैग्नेटिक पाथ है उसका मीन लेंथ होता है ये. जैसे अभी हम लोग एक ये वाला एग्जांपल देखे थे ना मैग्नेटिक सर्किट का, ये तो इसमें
यस
जैसे
सर।
कि फ्लक्स जो फ्लो कर रहा है दैट इज थ्रू दिस कोर, राइट? So
यस
here
सर।
you will have to calculate. L basically represents your mean core length, right?
ओके सर।
तो इसी से फॉर्मूला को यूज करके you can solve this circuit. And let us take one assumption here that no leakage of flux is taking place in this section. We will take this assumption only because practically there will be some leakage because here there is some another medium, that is air is the medium between these two parts of the core. यहाँ पे जो है मैग्नेटिक सर्किट में एक कट है and in that cut you have air gap as the medium, right? But even after that, let us consider that no leakage of flux takes place. नोट कर लिया तुम लोगों ने?
यस सर।
तो बताओ इसको कैसे सॉल्व करोगे?
सर वो जो एयर गैप है सर, उसमें तो फ्लक्स हमारा ट्रैवल करेगा नहीं, क्योंकि मतलब जैसे एक करंट को वायर से ट्रैवल होने के लिए वैसे उसको भी मैग्नेटिक मटेरियल चाहिए, तो सर
ऐसा
वो
नहीं
तो
है, ऐसा नहीं है. फ्लक्स फ्लो करेगा मीडियम में तो ऑलवेज देयर इज ए फ्लक्स. जैसे कि अभी मैंने एग्जांपल एक दिया था तुम लोगों को डीसी मशीन्स का कि जैसे कि यहाँ मान लो कि फील्ड प्रोड्यूस हुआ है नॉर्थ एंड साउथ ड्यू टू द फील्ड एक्साइटेशन. and here you have armature on which armature conductors are there, तो फ्लक्स जो है वो तो फ्लो करेगा ही, देयर विल बी लाइन ऑफ फोर्स। अब यही तो बताया गया था पहले क्लास में भी, लास्ट क्लास में भी, कि मान लो कि कोई मैग्नेटिक मटेरियल है, इस तरह से किसी मैग्नेटिक मटेरियल पे एक वायर जो है वुंड किया गया, यहाँ पे अगर एक्साइटेशन दोगे, then there will be a flow of current. Due to the flow of current, there will be development of flux, right? तो फ्लक्स की वजह से जो होगा एक EMF डेवलप होगा if there is a rate of change of flux through that conductor. So flux will be there, yes, but the amount of flux practically that will reduce because air will have higher value of reluctance than the magnetic material, right? So the value of that flux will be lesser. ये तो डिफिनीशन भी है ना रिलक्टेंस का कि which opposes the or restricts the flow of flux, जैसे कि resistance restricts the flow of current in an electrical circuit, there will be flux. So you have to basically use the same
सर फिर इसको दो
हाँ
पार्ट में सर करेंगे, एक फ्लक्स जो कोर में है और प्लस फ्लक्स इस एयर गैप में है, तो मतलब वहां से
राइट
निकालेंगे।
राइट, तो इसमें वही करना पड़ेगा कि एमएमएफ वाला फॉर्मूला यूज करना पड़ेगा जो अभी डिराइव हम लोगों ने किया है, जैसे कि ये वाला फॉर्मूला भी किया है ना हम लोगों ने डिराइव, फ्लक्स इज इक्वल टू mmf by reluctance. So first of all you will have to calculate the reluctance of these two parts, one for this magnetic material and one for the air gap, right? Length, everything has been mentioned in the question, length of the air gap, right? Area, length of the core IC is also mentioned, the mean length of the core is given, then area of cross section of the core is given. So based upon these value, using this expression, you will have to calculate the total mmf, which will have two components, one due to the magnetic material and another due to the air gap, right? And then you can calculate the required things. Just formula है और कुछ नहीं, दोनों को ऐड करना पड़ेगा, right? वही दिया हुआ है यहाँ सॉल्यूशन में भी, बट सॉल्यूशन आई विल नॉट शो यू राइट नाउ, ये तुम लोग खुद से करो। उसी तरह से और भी क्वेश्चंस हैं रिलेटेड टू दिस मैग्नेटिक सर्किट दैट आई विल गिव यू इन द असाइनमेंट, राइट? अभी इसको स्किप करूंगा मैं because this is just related to your formulas used. There are different questions that I will give you in the assignment at the end of this chapter. Now, next part, we will see the direction of current in a conductor, right? So first of all, let us consider three cases here. So here, suppose this is the first one, when there is no current. So this type of conductor, if it is mentioned like this, if any conductor is mentioned like this, it means that no current is flowing through the conductor, right? Now in the second case, suppose if cross is mentioned inside the circle, it means that current carries means conductor is carrying the current away from the page, means inside the page. क्रॉस का मतलब assumption ये है कि अंदर की तरफ करंट जा रहा है, ठीक है? तो सेकंड ये तुम्हारा कंडीशन है, एंड थर्ड वन, if dot is mentioned, it means that it is coming outside the page, right? Means जो तुम जैसे पढ़ रहे हो तो तुम्हारी ओर करंट आ रहा है, right? Now there are some other laws that we will see here. All these laws are basically related to the magnetic circuits or electromagnetic circuits. So there are some rules, right hand rule. So the direction using this right hand rule, we can estimate the or find the direction of the magnetic flux in any circuit, right? So इसमें करते क्या है ये हेलो
सर
हेलो
आपका वॉइस नहीं आ रहा।
अभी आ रही है आवाज?
यस
हेलो
सर। यस सर।
ओके 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 थैंक यू so suppose there is a conductor, this is the conductor, and in which the direction of current is mentioned in this form, means upward direction. So what you have to do, you have to put your thumb in the direction of the current, right? So after that, the direction of the closed fingers will give you the direction of flux flowing through that circuit, right? तो जैसे कि यहाँ तुम लोग इजिली कर सकते हो, सपोज अपने पेन को कंसीडर कर लो कि अपवर्ड डायरेक्शन में करंट फ्लो हो रहा है, सो इट विल बी counterclockwise direction will be the direction of the flux. So you can now think about these two cases, means when there are dot and cross. So dot का मतलब अभी हम लोगों ने क्या assumption consider किया, current is coming towards you, towards the reader. तो थंब को रखेंगे करंट के डायरेक्शन में, थंब को रखो करंट के डायरेक्शन में, so you can see that this will be the direction of the flux in the anti-clockwise direction. Again cross means current going inside the page, तो थंब को रखो inside the page की ओर, मतलब पेज के ऊपर रखो, so you will see that clockwise will be the direction of flux in this case for the currents going inside the paper. इसमें किसी को कोई कंफ्यूजन बताओ? दिस इज वेरी सिंपल, ये बेसिक फिजिक्स में भी तुम लोगों ने पढ़ा होगा. नाउ सेकंड लॉ इज योर Faraday's law of electromagnetic induction. So whenever there is a variation of magnetic flux linking a coil, and EMF is induced in that coil, so the magnitude of this EMF is proportional to the rate of change of flux linkage, means minus d phi by dt के directly proportional होता है. So according to this Faraday's law of electromagnetic induction, E will be directly proportional to d phi by dt. So if there are n number of turns in a coil, then it will be E is equal to n d phi by dt. This is your magnitude, but here one additional law is there due to which this minus sign comes here. This is due to the Lenz law. So what is the Lenz law? Lenz law states that the induced EMF in a coil will induce a current whose direction is such that it opposes the cause producing the EMF. Means simply Lenz law ये कहता है कि effect always opposes the cause. So what is the effect? So in order to understand this, let us consider one inductor or coil, right? So इसके across, suppose if we are exciting this inductor or coil with the help of some external EMF, so sin omega t, let us consider that. So when the circuit will be completed, a current will start flowing through this circuit. Suppose I is equal to Im sin omega t. This is time varying. We have considered the AC source, voltage source, due to which a AC current will flowing through the circuit. Now, according to Faraday's law of electromagnetic induction, what will happen when a current will link any coil or conductor? तो होगा क्या उससे? तो करंट जब फ्लो करेगा तो फ्लक्स पहले प्रोड्यूस होगा. दैट फ्लक्स विल बी अगेन टाइम वेरिंग इन नेचर. फ्लक्स जो होगा वो भी टाइम वेरिंग होगा, बिकॉज योर करंट इज टाइम वेरिंग. Flux will be also time varying in nature. So when the flux is time varying, so there will be rate of change of flux in this coil or conductor. Suppose there are n number of turns in this coil. So what will happen? So due to Faraday's law of electromagnetic induction, when rate of change of flux will be there through this coil, so EMF will be induced, ठीक है, n d phi by dt. अब लेंज लॉ ये कहता है कि the effect always opposes the cause. So this E is basically developed across this coil. So how it will oppose the cause? What is the effect here? Effect is your the induced EMF across the coil. And what is the cause? Cause is the flow of this current, I, sinusoidal current. So this E is going to oppose I only if this is the polarity of the induced EMF. ठीक है, अब ये एक एडिशनल वोल्टेज सोर्स की तरह अगर तुम इसको E को कंसीडर करते हो तो इसका मतलब क्या होगा कि इसकी वजह से कुछ करंट इधर फ्लो होना चाहेगा. इट मींस इट विल अपोज द कॉज, राइट. अब मान लो कि यहाँ पे निगेटिव हो जाता है, यहाँ पॉजिटिव होता, तो इधर इसकी वजह से भी इधर करंट फ्लो होने का टेंडेंसी रहता. So in that case there was no opposition, there will be no opposition of the cause. So due to this reason this will be the polarity of the EMF generated across the coil. So this is the Lenz law. So there will be minus sign. ठीक है. Now we will talk about self inductance. So let us consider a coil. Here we have a coil. This is the coil, and it has n number of turns, right? So when a current, suppose I, when a current I will start flowing through this circuit, then what will happen? A flux will be developed. ये flux develop होगा, ठीक है. So as per Faraday's law of electromagnetic induction, there will be some voltage induced across this coil, right? तो उसका वैल्यू मैग्नीट्यूड अगर हम लोग देखेंगे तो n d phi by dt होगा, right? So now this flux phi is produced by this current I, right? And hence any change in this flux will directly influence, means this flux magnitude will be directly influenced by the current changing through the network, right? So therefore we can write this voltage expression in this form: V is equal to n d phi by di into di by dt, right? Which is basically equal to your V is equal to L di by dt, where L is your inductance of the coil, which is equal to L is equal to n d phi by di. ये कहाँ से आता है? phi is equal to li जो रिलेशन होता है वही है ये बेसिकली तुम्हारा, right? So this inductance is basically known as your self inductance of the coil, this, right? क्योंकि इसमें जो मतलब EMF जनरेट हुआ है, this is due to the current flowing through this coil only, right? Now we will talk about the mutual inductance. So mutual inductance is basically the ability of the one conductor to induce a voltage across a neighboring conductor or inductor, right? It is again measured in Henry, right? The polarity of mutual voltage is determined by using dot convention. एक dot convention use किया जाता है, अभी देखोगे तुम लोग क्या होता है. ये suppose this is your electromagnetic circuit. So here you have two set of coils. Suppose this one is your L1 and this is your L2, right? The inductance of first coil is L1, inductance of second coil we have considered as L2. So the mutual inductance here we have to calculate, right? So now depending upon the direction of flow of the current through this circuit, we place or we identify the same polarity point, right? ये कैसे करते हैं सेम पोलैरिटी पॉइंट? इसके लिए टेस्ट किया जाता है बेसिकली, पोलैरिटी टेस्ट. पोलैरिटी टेस्ट, ठीक है. तो पोलैरिटी टेस्ट में हम लोग करते क्या है कि हम लोग किसी दो कॉइल के क्रॉस ये एस्टिमेट करते हैं और पता करते हैं कि कौन कौन सा दो पॉइंट सेम पोलैरिटी पे. सपोज दीज टू पॉइंट्स आर एट द सेम पोलैरिटी, द अपर पॉइंट, सो वी विल प्लेस डॉट एट दीज टू अपर टर्मिनल्स ऑफ द कॉइल. अब मान लो कि एक यहाँ पे निकल रहा है और एक यहाँ पे आ रहा है, तो यहाँ डॉट होगा, यहाँ कुछ नहीं होगा, ठीक है. तो इसमें नॉर्मली हम लोग ऐसे करते हैं कि मान लो कि ये एक सेम सिस्टम है, इसको शॉर्ट कर दो और अपोजिट एंड पे एक वोल्ट मीटर लगा देते हैं, वोल्ट मीटर. सपोज इफ वोल्टेज डेवलप्ड अक्रॉस दिस फर्स्ट कॉइल इज V1, this is V2. So if V is equal to your V1 minus V2, इसका मतलब सेम पोलैरिटी सही है, जो दो कॉइल है उसका पोलैरिटी सही है। तो अब ये कब आएगा V इज इक्वल टू V1 माइनस V2? तो मान लो कि यहाँ से स्टार्ट करते हैं हम लोग KVL लगाना और इस सर्किट में मूव करते हैं। तो अगर ऐसा है, मान लो यहाँ भी है, यहाँ प्लस है, यहाँ माइनस है, तो यहाँ से स्टार्ट करो, माइनस से प्लस की ओर जा रहे हैं, इसका मतलब plus V1. Then at this point you are going from positive to negative terminal, so this will be minus V2. So this will be the voltage measured by this voltmeter V1 minus V2. उस केस में क्या कहेंगे हम लोग कि ये दो पॉइंट जो है सेम पोलैरिटी पे। अब मान लो कि इस तरह का सेम सर्किट है, मैग्नेटिक सर्किट इस तरह का, इस फॉर्म में ये है पॉजिटिव, ये है नेगेटिव, ये है नेगेटिव, ये पॉजिटिव, ठीक। यहाँ वोल्टमीटर लगा दिए, इसको फिर शॉर्ट कर दो अपर एंड को। नाउ यू अप्लाई KVL in this circuit and get the reading of the voltmeter. So here you will find plus V1 plus V2, V1 plus V2. This will be the reading of the voltmeter. So in this case this will be dot and this will be dot, दोनों का positive polarity होगा। So this is basically your polarity test, right? So a dot is placed at one end of each coupled coils to indicate the direction of the magnetic flux if current enters that dot terminal of the coil. So this is the dot convention in order to find the polarity, means same polarity point. Now,
हेलो सर।
yes.
सर ये वाला तो समझ में आ गया, जो आप ये बता रहे थे कि वायर शॉर्ट करा दो और फिर एक वोल्ट मीटर लगा दो, अगर V इज इक्वल टू V1 माइनस V2 आएगा तो वो सेम पोलैरिटी पे होंगे। लेकिन सर फिर मतलब उससे क्या पता चलेगा सर? ये 12th में तो हमने म्यूचुअल इंडक्टेंस ये पढ़ा था, जो मतलब इसमें कुछ μN L1 इक्वल टू μ2 L2 ऐसे कुछ करते थे सर। तो
कौन सा
सेम सर, ये म्यूचुअल इंडक्टेंस के लिए हम लोग मतलब μ1 L1 इज इक्वल टू μ2 L2 ऐसे कुछ करते थे। तो सर मतलब सेम पोलैरिटी डिटरमाइन करके क्या मिलेगा सर? मतलब ये नहीं समझ में आ रहा।
यहाँ पे हम लोग म्यूचुअल इंडक्टेंस कैलकुलेशन अभी नहीं हो गया, अभी हम लोग आगे पढ़ेंगे। हम लोग अभी ये देख रहे हैं कि मतलब कैसे जो है सो सेम पोलैरिटी का पॉइंट डिटरमाइन करते हैं। बिकॉज ये सब तुम लोग पढ़े होगे कि एडिटिव पोलैरिटी क्या होता है, एडिटिव पोलैरिटी, सब्सट्रैक्टिव पोलैरिटी, जैसे कि L1 प्लस L2 माइनस 2m हो जाता है, L1 प्लस L2 प्लस 2m हो जाता है, ठीक है। फिर उसी तरह से M1 M2 माइनस सॉरी L1 L2 माइनस m स्क्वायर बाई L1 प्लस L2 प्लस 2m। तो ये मैं उसके बारे में बता रहा हूँ कि अगर म्यूचुअल इंडक्टेंस सपोज वी हैव टू कैलकुलेट, जो जैसे कि पहले कोएफिशिएंट ऑफ कपलिंग कैलकुलेट करते हैं, उसके बाद इक्विवेलेंट इंडक्टेंस कैलकुलेट करते हैं किसी भी पैरेलल सर्किट में या सीरीज मैग्नेटिक सर्किट में, तो उसके बारे में बता रहा हूँ। इससे कोई रिलेशन नहीं है अभी जो म्यूचुअल इंडक्टेंस हम लोग बात कर रहे हैं, ये यहाँ आगे हम लोग पढ़ेंगे, अभी कैलकुलेशन ऑफ म्यूचुअल इंडक्टेंस।
ओके सर।
So suppose here we have to calculate the mutual inductance through this in this magnetic circuit, electromagnetic circuit. So consider, we have considered here two coils. First one is suppose this one, coil 1, this is your coil 2. So each coil having the self inductance of suppose L1 and L2, which is mentioned here, L1 and L2. Now again let us consider that this L1 coil has N1 number of turns and this second coil having N2 number of turns, right? So here we are not going to excite the secondary coil or second coil. ये जो second coil है L2, इसमें हम लोग कोई additional excitation नहीं produce कर रहे हैं, even though there will be the development of EMF across this second coil L2, right? How? That we can explain through the mutual inductance principle, right? So suppose here we have excited the first coil, L1 coil, with the help of, here current source is mentioned, but let us consider a voltage source, because normally voltage source is used for the excitation purpose. We have normally voltage sources available, right? करंट सोर्स मेनली तुम लोग के एरिया में इलेक्ट्रॉनिक्स में ट्रांजिस्टर्स जितने होते हैं वो करंट सोर्स होते हैं, दैट आर द प्रैक्टिकल एग्जांपल्स ऑफ करंट सोर्स। तो इसको भूल जाओ। मान लो कि वोल्टेज अप्लाई करते हैं कुछ VT और V1T, so due to which a current I1 is flowing through the first coil, right? So when I1 will flow through the coil L1, so it will create a flux phi1, ठीक है, ये सही है। So now what will happen, this flux will have two components, right? First component will be the component of phi1, which will link only with coil 1, जो coil 1 है उससे जो link कर रहा है, right? And second component will be the flux linked with both the coils। मतलब कहने का मतलब ये है कि मान लो कि दो coil है इस तरह से कुछ, सेम सर्किट वी वांट टू ड्रॉ। तो जब ये L1 है, ये L2 है, तो इसमें जो करंट फ्लो कर रहा है कुछ I1, तो देयर विल बी सम फ्लक्स डेवलप्ड। तो कुछ फ्लक्स जो है, जैसे कि ये वाला पार्ट जो है लेफ्ट में दिखा रहा है, दिस इज ओनली लिंक्ड विद कॉइल L1, बट देयर विल बी सम flux lines that will link both the coils L1 and L2, right? So the combination of these two components of the fluxes, that is phi 11 and phi 12, is your total flux linked with coil or produced due to the flow of current I1 through the coil L1, right? So you can see that even if the two coils are physically separated from each other, they are magnetically coupled with each other। इलेक्ट्रिकली आइसोलेशन में है दोनों कंडक्टर और कॉइल, देयर इज they are not in physical contact with each other, but they are magnetically coupled, right? Then what will happen? So due to the flow of current I1 through coil L1, there will be a development of voltage because of Faraday's law of electromagnetic induction. This we have already discussed, and this expression we have already seen in the previous slide, right? So this is your voltage induced, magnitude of the voltage induced across the first coil. Now if we want to calculate the voltage induced in the second coil due to the flux linkage phi12, अब phi12 क्या है? This is basically the component of total flux, right, which is phi11 plus phi12। अगर if there is flux linkage with the second coil, then obviously there will be some induced EMF across the second coil also because of the Faraday's law of electromagnetic induction. So now voltage induced in the second coil will be how much? This will be V2 is equal to N2 d phi 12 by dt। d phi 12 क्या है तुम्हारा? The flux which is linking with the second coil, which is basically a part of the total flux of coil 1, right? So again this can be transformed in this form and you can easily calculate the value of mutual inductance, right? So here M is your mutual inductance, which is equal to N2 d phi 12 by di1। समझ में आया ये या नहीं समझ में आया, पहले ये बताओ। बताओ। मीन्स समझने का सिर्फ यहाँ पे यही चीज है कि the coils are not in contact with each other, इलेक्ट्रिकली आइसोलेशन में है दोनों coil, right? But they are magnetically coupled to each other. Why they are magnetically coupled to each other? Because when a current flowing through coil 1, that current is producing a flux, so some part of the generated flux is linked with the first coil only, whereas the other part of the total flux is linked with both the coils, coil 1 and 2, having inductance L1 and L2, right? So due to this reason, if the rate of change of flux will be there through the second coil due to the presence of this flux phi12, there will be some induced EMF V2 across the second coil, ठीक है? तो यही है म्यूचुअल इंडक्टेंस प्रिंसिपल, और कुछ नहीं है। ठीक है. So in this way you can calculate the expression for mutual inductance between the first and second coil or conductor. So similarly second thing in this way also you can assume कि जैसे कि अभी फर्स्ट केस में हम लोगों ने क्या कंसीडर किया, वी हैव एक्साइटेड द फर्स्ट कॉइल विद द हेल्प ऑफ ए वोल्टेज सोर्स. Now alternately you can do that, you can excite the second coil and you can estimate or calculate the expression of the mutual inductance here. तो इस केस में भी तुम कर सकते हो कि mutual inductance कितना होगा when we are exciting the second coil, right? The process will again remain same, there is nothing new here. होगा change क्या कि I2 के flow होने की वजह से phi2 develop होगा, so some part of the phi2 will be linked with the second coil only, whereas the different another part will link both the second as well as first coil, so due to which there will be the development EMF across the first conductor also or first coil also, so the value can be calculated accordingly. ठीक है, किसी को कोई कंफ्यूजन है तो पूछो, अदरवाइज वी विल एंड द टुडेज क्लास, टाइम हो चुका है. एनी क्वेश्चन? हेलो.
हेलो सर.
हाँ,
सर ये 522 क्या है सर?
phi22 here is the flux which is linked with coil 2 only. ये सेकंड केस हम लोगों ने लिया है. अभी पहले केस में क्या हम लोगों ने कंसीडर किया था कि we have excited the first coil that is L1, जो कि यहाँ पे था, इससे पिछले वाले स्लाइड में. एक मिनट रुको. ये जैसे कि यहाँ फर्स्ट केस में क्या था कि when the current I1 was flowing through L1, तो टोटल फ्लक्स जो था phi1 उसका दो पार्ट था, phi11 प्लस phi12, राइट. तो phi11 क्या था बेसिकली, द फ्लक्स व्हिच वाज लिंक्ड विथ कॉइल 1 ओनली, एंड phi12 क्या है, द फ्लक्स व्हिच इज लिंक्ड टू बोथ द coils L1 and L2. So this is your self flux, phi11 is your self flux and phi12 is your mutual flux. तो म्यूचुअल फ्लक्स की वजह से जो इंडक्टेंस डेवलप होगा दैट इज बेसिकली योर म्यूचुअल इंडक्टेंस. सो सिमिलरली नाउ हियर, यहाँ पे जो तुम पूछ रहे हो इसमें क्या है कि यहाँ पे देखो, यहाँ पे अब क्या किया हम लोगों ने कि जो सेकेंड कॉइल था L2 उसके अक्रॉस एक कोई वोल्टेज सोर्स सपोज लगा दिया, E2 और V2 व्हाटएवर, उसकी वजह से करंट I2 फ्लो होगा सेकेंडरी कॉइल में L2 में. तो I2 की वजह से जो फ्लक्स प्रोड्यूस होगा, सपोज phi2, इट विल हैव टू कंपोनेंट, phi22 प्लस phi21. सो phi22 इज द सेल्फ फ्लक्स, दिस इज योर म्यूचुअल फ्लक्स which is linked with both the coils. इसीलिए म्यूचुअल बोला जाता है कि दोनों कॉइल के थ्रू लिंक कर रहा है वो फ्लक्स. ठीक है,
तो फिर वहाँ पीपीटी में सर कॉइल 1 के जगह कॉइल 2 होगा सर, यहाँ पे 522 लिंक्स विद कॉइल 2 ओनली.
वही तो कह रहा हूँ, ये दोनों अलग अलग केस मैं समझा रहा हूँ. पहले केस में जो था वहां यहाँ पे हम लोगों ने लगाया था वोल्टेज सोर्स, ठीक है, और तब हम लोग कैलकुलेट कर रहे थे कि कितना ईएमएफ इंड्यूस हो रहा है सेकेंड कॉइल के क्रॉस L2 के क्रॉस. अब उसका जस्ट वाइस वर्सा वी आर डूइंग, वी आर एक्साइटिंग द सेकेंड कॉइल एंड वी वांट टू कैलकुलेट द वोल्टेज इंड्यूस्ड अक्रॉस द फर्स्ट कॉइल L1. ये सेकेंड केस, ठीक है.
यस सर फाइन.
ओके, और कुछ किसी का कोई डाउट? चलो, नो डाउट इज देयर. तो तुम लोग ऐसा करो कि ये सब मेरे ख्याल से कुछ बेसिक्स फिजिक्स में भी पहले पढ़े होगे, तो एक बार उसको रिवीजन कर लेना, और बाकी फिर कुछ पार्ट बचा है इस मैग्नेटिक सर्किट का, वो हम लोग पढ़ने के बाद फिर ट्रांसफार्मर स्टार्ट करेंगे. ठीक है, एक क्लास और मैक्सिमम मैग्नेटिक सर्किट में लगेगा. आफ्टर दैट वी विल स्टार्ट द सिंगल फेज ट्रांसफार्मर। एक बार लेकिन रिवीजन जरूर कर लेना।
हेलो सर।
हाँ
सर मतलब सर कुछ नोट नहीं कर पा रहे थे, काफी तेज चला था, तो सर ये पीपीटी मिल जाएगी क्या सर मेरी?